Well, back tuning into today's video. Well, here we go. We're starting the winter 2014-2015 updates today. I did a video last week, of course, explaining the different things we'll be looking at. This is the start of it all this week. We're going to be doing these updates regularly every other week, start off with probably every week later on in the autumn, as we build up towards the final and official GasWeathers.com winter 2014-2015 forecast, which will probably be at the very end of November or at the very start of December. Haven't penciled in the exact date for that just yet, but it'll certainly be around the end of the autumn or the start of the winter. We're going to get several elements together, and I explained those different elements on the methodology video last week. See how they're looking today as we start off, and then of course we'll monitor the situation through the course of the autumn. It'll all make sense as we go along. Now, before I get on with that, I'll say about the advertising. My video ads, my pages at GasWeathers.com. You hit play on video ad. You'll be helping to support GasWeathers.com. Thanks so much for doing that. The video ad essentially pays the website, allows me to sit here and talk to you via website. So if you could get involved and play the video ad, you'll be helping to support GasWeathers.com. Thanks so much for doing that. And just say thank you very much to Asab from Germany. He emailed me some very interesting information related to El Nino and the effects it can have on UK and European climate. A few months ago, I've been sitting on that information, but you're going to see it today. You're going to see it at the end of the video. Very, very interesting information that is going to be. I can probably just hang around for the end of the video to see the charts from Assam. So we're going to start off first of all with the hurricane season. Now, I didn't explain this actually in the video last week, the methodology video. I'd like to look at the Atlantic hurricane season, see how that's developing, and I didn't have time really to fit it in last week. It's one of the I rank some of these things as more important than the others, and this idea is a little bit less important. I think it does make up part of the picture, but it's not as important really as some of the other things that we look at. So I didn't have time to put it in video last week, but we're going to start off with it this week anyway. Now, the idea behind this is that hurricanes basically are transporting heat, energy from the tropics, and they're dumping them up in the pole. That's basically the idea, dumping the heat over the North Pole. It's sort of the Earth's thermostat, or one of the Earth's thermostats work. The Earth is always looking for an equilibrium. It's always looking to find balance between hot and cold, wet and dry as well. And hurricanes are one of the ways that it does that. Also, tropical storms, typhoons, of course, in the Pacific. But once that heat is dumped into the Arctic, it can sort of help to feed back later on into the form of blocking. So you get a season with lots and lots of hurricanes. It can sort of be one of the signals that you could get some colder block type conditions later on as you get through to the winter. So let's see where we are with the current hurricane season anyway. And well, we already got more hurricanes than last year. We hardly had any. I don't think we had any, did we? Anyway, we've got 3 hurricanes. We've had 3 hurricanes so far this year, and total tropical storms coming out at 4 so far. Total depressions coming out at 5. But the main number is the hurricanes. 3 hurricanes. No major category 3 or above hurricanes just yet, but we have at least had 3 hurricanes. It's a start. We're still early in the season. We've got the whole of September, October, and the start of November to go. And compared to last year, when actually we had 2 hurricanes, so we're already doing better than the whole of the season last year. This is 2013, a summary from 2013 on Wikipedia. And yeah, we had 2 hurricanes throughout the whole of the season last year. So already, this early stage of the season, we're doing better than we did in 2013 for hurricanes. But by no means very active season, not yet anyway. But as I say, we've got to wait for September and October. And you'll be interested to see how those hurricanes stack up through the course of the autumn. As I said, there is a bit of a feedback mechanism going on there, where there's lots of hurricanes dumping lots of heat in the Arctic. It eventually can feed back into the form of blocking. Next thing we're going to talk about is solar activity. This is from solarham.net. The image of the solar disk on our side of the disk today. And what we're seeing here is that we've got quite a few sunspots over here on the far left hand side of the solar disk as you're looking at it. But overall, solarham.net is saying that the amount of sunspots, the solar activity today, is officially low. So we've got officially low activity today, and that's been the case really through certainly most of the summer, particularly August. Hasn't had a great deal of activity going on. We'll look at this in more depth, I think, next week. We should have an update from NASA next week, so have a look at it in more in depth next week. But I think the overall idea is that after we had the ramp up through the course of last winter in solar activity, we are seeing a gradual decline now taking place. I think with past solar maximum, we should see things easing off in terms of sunspots now through to solar minimum. But that's not going to be a linear process, so we can expect further spikes upwards. And if one of those spikes upwards, for instance, happens to coincide with this winter, it can have an effect in enhancing the jet stream. But overall solar activity at the moment is low. We're moving towards the an easterly QBO. You can see the easterly and westerly phases of the QBO on this graph between the white areas and the grey areas. So, for instance, this white area just here through 2012 into 2013 is telling us that we've got an easterly QBO during that period through the winter of 2012-2013 was a cold winter, of course, and then the grey area here is telling us that we've got a westerly QBO through winter of 2013-2014. Now, westerly QBOs enhance the jet stream. Basically, you're strengthening the zonal westerlies around the northern hemisphere in a westerly QBO. An easterly QBO is sort of a weakening, a slackening off, if you like, of the zonal westerlies around the Earth, and you're getting a greater chance of sort of getting easterly zonal winds, and that can transfer into an increased chance of blocking. So we're going to have an easterly QBO winter this year. You can see that quite definitively really on this chart, that this white area is getting bigger. That is going to sink down something like that through the course of this coming winter. So we'll have an easterly QBO just there. That's a little bit askew, my drawing. If you watch my videos regularly, you'll know that my drawing isn't great, but there's going to be an easterly QBO winter anyway. We'll be in that sort of phase through the course of winter. It's not as straightforward as every QBO coinciding with every cold winter, though. So we're going to look at this in more depth in a subsequent update. Can't say exactly which one it'll be, but I will be looking at past QBOs, maybe comparing them to El Nino winters. That would be interesting, wouldn't it? Because I think we're going to have an El Nino this winter, but it's going to be an easterly QBO anyway, which does help our chances of getting more blocking this winter, certainly in comparison to last winter, but it's not that straightforward. Now, we're going to have a look at snow cover and Arctic sea ice extent next. This was the situation across the Siberian plain from NOAA this time last week when I did the methodology video. We had some snow cover there building up across that very limited part of northern Siberia. Let's see how that's developed. We've gone through the course of the past week. So here we are going through excuse me, to the chart for the 5th of February today when I'm doing the video, and you can see that actually there's not really been a great deal of development there. We have more or less got the same amount of snow cover that we had before. If we go back, that was the situation last week, go forward. Yeah, not a great deal of development. We've lost a bit up there, we've gained a little bit down there, but overall not a great deal going on. It's about where you would expect us to be, maybe a little bit above where you would expect us to be this early in the autumn. This will become much more important as we get through to October and the start of November, because eventually this whole Siberian wilderness all the way back to Western Russia and Eastern Europe is going to fill up with snow, and it's going to be exactly how that happens, how quickly it happens, and most importantly where it happens, perhaps to determine what effect this could have on our winter prospects, but it's going to be something we'll look at in far more depth, I think, as we get through towards October. But so far, it's okay, nothing special, nothing terrible, and it's too early to be concerned about that anyway, to be honest. What I want to look at next is the ice cover extent. Let's just go back and show you the ice as it is right now. This is how much is melted. These blue areas up here in the Arctic, the yellow areas are where we've still got ice. It does look as though we've lost quite a lot of ice there, doesn't it? But if we go through and have a look at this graph, we're actually doing very well. We're above every other year at the moment in terms of how much ice we've lost, except for 2006. 2006 is this blue line just here, and yeah, you can see quite clearly that we're above all the other lines. We're certainly nowhere near the death spiral years of 2012, which is this one just here, a terrible melt season, and we're not as bad as 2007 and perhaps 2008, these sort of this cluster of lines just here. 2011 as well was a pretty bad one, so we're doing really good, really quite good for the ice melt season at the moment. If you're worried about the Arctic sea ice melting, how much we lose through the course of the melt season, then this is very good news, because it is the best we've been really since 2006, and 2006 was the last time you say we've had a fairly decent melt season. Now, the effect of this on our winter weather, why I'm including this, is that when you lose a lot of ice from the Arctic, such as these years, from the so-called death spiral years, 2012 for instance, there is idea that it can feed back over time into an increased chance of blocking. There's not a great deal of evidence for it, not a tremendous amount of research has been done really, but it's one of those ideas that's out there, that when you lose a lot of ice over the Arctic, it can eventually feed you back into a course of sort of non-blocking through the course of the winter. So the fact that we haven't lost too much ice this year, we have lost some ice of course through melt seasons, but we're doing better than most other years except 2006, perhaps sort of negates from the idea that we're going to have a lot of Arctic blocking. But as I say, there's not a great deal of evidence either way for this, and overall it's just very good news, I think, that we're not seeing a tremendous amounts of ice being lost so far anyway this year. So let's go on and have a look at El Nino and the situation in the oceans first of all. Now, the Atlantic is very interesting at the moment. I'm getting more interested in what's happening in the Atlantic. Got this warm area just here. It's not quite in the tropics, but with this cooler area just here, and then warmer area again to the south of Green, you have to say we're not that far from a tripole there, are we? I would like to see this area further south becoming a bit warmer, so this whole area just here sort of incorporates that warmer zone. And of course, I'd like to see cooler waters developing through this zone just here. But overall, we're not that far away from a tripole there, so we're going to have to wait and see how that develops. That is quite interesting. Notice as well that the Pacific is warming. This is, by the way, this is from NOAA, and it was generated on the 4th of September, this sea surface temperature anomaly, and very clearly we've got some warming beginning to take place through the equatorial Pacific. I did say that as this cooler area just here, going from Peru and stretching up towards the equatorial Pacific, I did say in the last El Nino video that as that sort of dies away, as that area shrinks, it should start to allow warming beginning to take place through here, and that's definitely how things are trending at the moment. Definite signs now that things are starting to happen through the course of the equatorial Pacific. Let's have a look at the SOI, the Southern Oscillation Index. This is the SOI for monthly periods, going a long way back. Actually, you can go to the 1870s with this chart, but what we're interested in is this just here. This is 2014, and notice that for August the Southern Oscillation Index number comes out at minus 11.4. Now, when the Southern Oscillation Index is negative, when you're into minus territory, that is telling you that the atmosphere is coupling up with the ocean to begin to produce an El Nino, and we've had our third significantly negative month in terms of the SOI since March, when we went down to minus 13.3. There was a lot of speculation at that time that we might be in for a so-called mega El Nino event, but of course it didn't happen because we went positive with the SOI through April and May. When you're positive, you're sort of fighting against the El Nino, going into La Nina territory in terms of the atmospheric setup. But very interesting, Matt, for August we did go significantly negative with the SOI, and that's allowed that warmer water to begin to develop through the course of the equatorial Pacific. So it does look as though it's finally happening now. The atmosphere and the oceans are coupling up. We're beginning to get the El Nino going. Let's see how the SOI has been performing through the course of September so far, and here we go. You can see that we're still significantly negative. These are provisional, but we're still significantly negative through the course of September, although the 5th of September actually posted a very, very slightly positive return at 0.36, but every other day through September has been significantly negative, particularly the 3rd of September when we got down to minus 13.9. Look how negative it was on the 30th of August, minus 26.0. That's very significant negative. You start getting many of those sort of numbers appearing on these daily charts from the Bureau of Meteorology in Australia, by the way. If you start getting those very significantly negative numbers appearing, then you really are hooking up the atmosphere and the oceans very, very nicely. So I think it's happening now. We are moving, finally, after so many fits and starts, we're moving towards the El Nino. The CFS is predicting this El Nino to take place. It's going to be, well, it's predicting a weak El Nino, really. It has trended down with time, but we're still just about reaching the threshold to get it designated in the end. It's very specific how you have to designate the El Nino. It has to be above 0.5 degrees of an anomaly over 5 tri-monthly periods. So what can happen with these El Ninos is that they never really get designated, but that doesn't mean that they don't have their impacts. Anyway, this is the forecast for from a CFS V2 model for region 3.4, which is sort of a central part of the Pacific, and yeah, it's indicating a weak El Nino going up to around +1 there, perhaps towards the end of the year. Certainly not a strong El Nino by any means, and really struggling to get to sort of the moderate level, but it is an El Nino. I think if that comes off, it will be designated. Now this is for the forecast for region 1.2. Let's just go back and explain what this is that we're looking at with this. Region 1.2 is this region just here off the coast of Peru. So that's region 1.2. 3.4 is this sort of area here in the central part of the Pacific. So what the model is telling us, if we go back, have a look at this, it's telling us that on the eastern part of the equatorial Pacific we're expecting cooling, and it's going to stay sort of below just about El Nino, the El Nino threshold in region 1.2 off the Pacific coast. But in region 3.4 we are going up into the El Nino threshold. So this is telling us, let's go back again, that this area in the central part of the Pacific is going to be warmer than the eastern part of the equatorial Pacific. That's a Modoki El Nino, or a Mediki, or however you want to pronounce it. I think there's some speculation about how you pronounce a thing, but it's a central based El Nino essentially, as opposed to a normal El Nino, which is pretty much uniform across Pacific Ocean, and generally the heat actually is in this area, specifically off the coast of Peru. Now those two different types of El Nino can have quite dramatic differing effects. So I want to show you this finally, but I was emailed by Assam a few months ago. This first of all is telling us, it's an anomaly chart showing us, or telling us, what the effects of an eastern Pacific El Nino are, or a regular, if you like, Pacific El Nino. Notice the warmth in that area of the coast of Peru particularly, but the whole of the equatorial Pacific is warm, but it's particularly over toward the coast coast of Peru. And you notice that in that sort of an El Nino, most parts of Europe are coming out warmer than average. The red colours, as with any normal anomaly chart, are above average, blue colours are below average. So yeah, through a normal El Nino, or an eastern based El Nino, we are seeing a trend there through most of Europe for warmer than average. This is from the Journal of Geophysical Research, by the way. It's a very interesting paper. But if you want to see what the effects of a central Pacific El Nino are, well, there we go. Look at that. Much colder there through most parts of Europe. And notice the difference through the equatorial Pacific. We've lost the core of the heat off the coast of Peru in that area, and we're generating it through that central part of the Pacific. That is the kind of El Nino, and central Modoki El Nino, that the CFS model is predicting for us this winter. And very often these late starting El Ninos, and this is definitely a late starter, these late starting El Ninos do tend to be more of a central base type as opposed to the early starters, which are usually very big El Nino events as well, like 97, 98, that tend to be more eastern based. But look how cold it is there across most parts of Europe on years that have this central El Nino. Bitterly cold. Anomalies, this is an anomaly scale just here, coming out to anywhere between around 2 and 3 degrees below average. Over here, we're on the periphery, of course, of the cold, as we always are for us. So the anomaly isn't quite as dramatic. Notice as well, by the way, that much of the east, southeast, and south of the States has a very cold winter with a central base El Nino. But for us, we're on the core of the cold, so it's not quite as dramatically cold. Nevertheless, we are below average. We're within the 0 to 1 degree below average category band. Now you can see the years that these two differing El Nino types have been based off on. The eastern Pacific El Nino, the mild one, is based on 51, 52, 57, 58, 65, 66, 72, 73, 76, 77, and 98. And that's wrong, it's saying 2008, but that should actually be 2006, 2007. And I can't disagree with that, because nearly virtually all of those are mild winters, to be honest, throughout those lists. Most of them are mild winters. 57, 58 did turn cold at times, particularly through January and again in March. 65, 66 had its moments as well, but overall pretty mild winters through those ones. If you have a look at the central based El Ninos, we've got 68, 69, very cold winter. 77, 78 was a cold winter. 86, 87, a cold winter, obviously. 94, 95, that's a different one. That's a mild winter, just telling us that, as ever, with any trend, any analogue, there's always going to be years that are different. And 94, 95 was a mild winter, very zonal winter. At the peak, of course, of the 1990s sort of mild spell, where every winter seemed to be mild virtually, and every summer, coincidentally, or most summers, seemed to be quite hot. Quite what happened in the 1990s, I'm not sure, but it was a very bad decade for anybody that likes cold winters. 2002, 2003, that was a pretty mild winter as well, so those two do deviate from this idea. For us, anyway, it was colder on the continent, I think 2002, 2003, particularly for Scandinavia, but for us, they were two milder winters in this list. And then we get to 2009, 2010, which obviously was a very cold winter. And quite interestingly, these first three, 68, 69, 77, 78, and 86, 87, had the colder weather towards the middle and latter stages of the winter. Actually, none of these years had particularly cold weather in the early part of winter. They were all cold later on, particularly 68, 69, 77, 78, and specifically 68, 69, which was a severely cold February. So I'll just go back up and show you that again. That is what we could be facing if we get this central based El Nino going this year. We did see from most lists that not every year with a central-based El Nino is a cold winter for us, but most of Europe, I think, is going to be in for it this winter. So if you know anybody on the continent, get them prepared, because I think you're going to know about it probably this winter. Whether it backs as far west as the UK and Ireland is always the question. That's going to be determined probably in the end by other things, but very interesting nonetheless, I'm sure you'll agree. So that's the first winter update. I'll be doing it again probably in a couple of weeks. Next week I think we're going to do the CFS 6 months look ahead, so come back to that. That's going to be very interesting. The CFS is starting to turn out some really interesting charts, so come back next week for the CFS 6 months look ahead. The next winter update, as I say, probably 2 weeks today. Hope you found the video interesting. By the way, this video will be kept around GavsWeatherVids.com for the foreseeable future, so if you're interested in watching this again, you wasn't able to watch it all in one sitting, don't worry about it. It'll be around the website for a long time to come. That's it for now. Hope you found the video interesting. Bye for now.